Yes. Welcome to the next session of Rehabilitation and Retrofitting of Structures course. In the last session, we have been learned the corrosion protection technique. In that, we have been learned the 3 corrosion protection techniques. So let us continue with a few more corrosion protection techniques in this particular session. So the next corrosion protection technique which I am going to discuss today is, that is number 4, cathodic protection. Cathodic protection. Okay, as the name itself indicates, we are going to protect the cathode. So let us see what exactly that is cathodic protection. This particular corrosion protection technique is extensively well known and commonly used corrosion protection technique to protect the steel from a corrosion. So in this particular process, how exactly it runs is, it is the application of impressed current to an electrode. Application of impressed current to an electrode laid on the concrete. That means, so this particular electrodes will be dipped inside the electrodes. In that particular electrodes, I am going to send or apply the impressed current. That is what the meaning of this sentence. Resting on or laid on the steel reinforcement. So the application of the impressed current to an electrode laid on the concrete resting or above the steel reinforcement. This is what the process. You can see from a photo or you can see from the figure how exactly this particular process runs. You can see on that particular the 2 electrode that will be dipped inside the concrete, reinforced concrete member. And these 2 electrodes will be connected to the monitoring system where you can monitor the electrodes. And that particular 2 electrodes, or through the 2 electrodes, I am going to send that impressed current. And then that particular electrodes which is laid on the concrete will be on resting or above the steel reinforcement. You can see all those things. Is it clear? And the next is this electrode, whatever this electrode will serve as this electrode will serve as anode. This electrode will serve as anode, and then steel reinforcement will serve as cathode. This electrodes will serve as anode and the steel reinforcement, you can see from the photo that steel reinforcement will be connected to the negative terminal of a DC. That means it is connected to the power supply. Negative terminal of DC. So that particular thing will be acting as a cathode. Electrode will be anode and the steel reinforcement connected to the negative terminal of DC will be serving as cathode. So this is what the components you can see from the photo. So whatever the thing have been written over here, that has been showcased in the photo. Is it clear? Next, how exactly this process runs? In this, the anode, you can see from a photo, that is electrodes, will be subjected to corrode, and the reinforcement will be protected and the reinforcement which will be serving as cathode will be protected. That's the name, it is called as cathodic protection. That means allowing the anode to get corroded, by protecting the steel reinforcement, from the corrosion. That is what the meaning of cathodic protection. Okay, is it clear? I will repeat. In this particular process, okay, the electrode which is serving as anode will be allowed to get corroded by protecting the steel reinforcement which is serving as cathode. Okay, that's the name cathodic protection. So that is what the process. Okay, that is what the process it does. Okay, how this works, how the things works inside, how this process works inside. Okay, you know that the chloride ions, okay, which will be the prone to cause a corrosion, or which I used to call a villain. Okay, that particular villain will get inside the concrete, will get inside the reinforced concrete member, okay, to create corrosion. Okay, so that particular chloride ion which enters, okay, in order to create a depassivation film on the surface of a corrosion reinforcement, so that chloride ions will be deviated. Okay, that chloride ions meant to deviate it. Okay, that chloride ions which will get inside the reinforced concrete member, okay, which try to attack the cathode part, to create a corrosion. Okay, here in this particular process, what I meant to do is that particular chloride ions which enter inside the reinforced concrete member, that chloride ions will drawn from the vicinity of that steel reinforcement. That chloride ions which will drawn from the vicinity of a steel reinforcement in such a way that that chloride will not allow to react or tend to depassivate. Okay, that's why that will drawn from the vicinity of that, okay, and tend to react with this anode, so that, okay, the chloride ion which entered inside the reinforced concrete member will try to react with anode. So that is what the process I am going to do. Okay, but you already know that this chloride ion will be always tend to, okay, react or attract with the cathode in order to create a corrosion. But in this particular process, what I have done is, okay, whatever the chloride ions that has been entered inside, that particular chloride ions, okay, tend to react with this particular anode, or I am going to create a process in such a way that that chloride ions will react with the anode to form a chlorine gas. Okay, what it does? It will create a chlorine gas. Okay, so that chloride ions which will drawn from the vicinity of a steel reinforcement, that means I have not allowed the chloride ions to react with the steel reinforcement. Hence, this chloride ions which has entered inside the reinforced concrete member will react with the anode to form a chlorine gas. So that's what the name cathodic protection. I am creating a protection technique by, okay, these phenomena. That is what they call cathodic protection. If I am going to protect the cathode in the reinforced concrete member, automatically you can, reduce the corrosion problem. So that's what the thing of cathodic protection. But the limitation is there of this method, or I can say the technique. The limitation of this particular technique is this technique is not widely used in India. Why? Because this is a little bit costlier technique. Okay, costlier in the terms of, I can say, in the money, okay, it will be little bit costlier, okay, it is not so economical, and they have been limited in the particular with Indian country. So that's why this cathodic protection technique is not widely used in India. So this is regarding your cathodic protection. I will repeat, okay, you can see that, okay, once again I am going to apply the impressed current through the electrodes which is, okay, laid on the concrete above the steel reinforcement. Here, okay, the electrodes will serve as anode and the steel reinforcement will serve as a cathode. And then whatever the chloride ions that will enter inside the reinforced concrete member to create corrosion, that chloride ions will going to create in such a way that chloride ions will drawn from the vicinity of a cathode, and we are allowing the chloride ions to interact with anode, okay, so that the chlorine gases will be formed, so that the steel reinforcement will be protected, no depassivating film will be formed. Hence, I am going to do the cathodic protection, which in turn I am going to do the protection of corrosion. So this is what the technique of, okay, cathodic protection or in the corrosion protection techniques. Is it clear? Hope the concept has been cleared. Okay, and whatever I have been highlighted, all those concepts I can see pictorially. Is it clear? Okay. Coming to the next cathodic protection, corrosion protection technique. The next corrosion protection technique is non-ferrous reinforcement. The next corrosion protection technique is non-ferrous reinforcement. Okay, non-ferrous reinforcement. What is this non-ferrous reinforcement? This is the one more corrosion protection technique we are going to use in order to what I can say, protect the steel from a corrosion. So first of all, this is an alternative. This is, I can say, alternative to the steel reinforcement. So non-ferrous reinforcement will be alternative to the steel reinforcement. That is the first thing. And the next is, which is that non-ferrous reinforcing material which I am going to use inside the concrete. Which is the non-ferrous reinforcing material which I am going to use inside the concrete, okay, so that this corrosion can be protected. The non-ferrous reinforcing material I am going to use here is fibers. Okay, the fiber will act as a non-ferrous reinforced material. Okay, so the fiber will act as a non-ferrous non-ferrous reinforcing material. Okay, so what is this fibers? Okay, so this particular fiber is predominantly used in civil engineering. Okay, and this fiber has came into existence in such a way that if you want to achieve a more tensile strength in the reinforced concrete, more flexural strength in the concrete, more toughness, more ductility in the concrete. We already know that a concrete is not a ductile material, concrete is not so tough as a steel. Okay, in order to improve these properties, that is toughness, ductile, okay, in order to improve these properties, these fibers are added inside the concrete as a reinforcing material, okay. And a very interesting thing in regarding to the fibers are, the fibers having a tensile strength, modulus of elasticity more than that of concrete. The fibers will be having a tensile strength, okay, and modulus of elasticity more than that of concrete, so that I can embed inside the concrete. Okay, so that the fibers will prominently or predominantly act as a reinforcing material inside the concrete member. Okay, and the next thing, the various types of fibers used are, okay, commonly used is steel fibers. Steel fibers. Number 2, okay, glass fibers, or also it is called as mineral fibers. Number 3, carbon fibers. So this fiber is most popularly used nowadays in the civil engineering. Okay, carbon fibers. Like this, we can also go ahead with the natural fibers. Natural fibers. Natural fibers are, I can say, sisal fibers. Okay, sisal fibers. Okay, next is polymeric fibers. Polymeric fibers or polymer fibers. So like this, different types of fibers are there, you can embed inside the concrete. And each fibers or different types of fibers will vary depending upon the physical properties. The physical properties of steel fibers will be different, the physical properties of glass fibers will be different, and carbon fiber will be different. In coming to the polymer fibers, you will be having a nylon fiber, aramid fiber, polyester fibers. Okay, and in this particular, the predominantly used is steel fiber, carbon fiber and polymeric fibers. So these three fibers, okay, steel fibers nowadays in all the concrete practices they are using these steel fibers, and carbon fibers nowadays it has got more potential compared to other types of fiber because of its predominant physical properties compared to other types of fibers, like in terms of tensile strength, modulus of elasticity, all those things. Is it clear? Okay, so these fibers I am going to embed. And a very important thing, and these things you already learnt in your concrete, once again I am going to, okay, memorize, or I can say glance these particular topics. Okay. And one more thing, a very important thing in the fiber is aspect ratio. Aspect ratio. You already know that aspect ratio. What is the meaning of aspect ratio? The aspect ratio is equal to length by diameter. So this plays a very, very important role. L by D ratio. As the aspect ratio increases, okay, there will be decrease in the, okay, the strength of a fiber reinforced concrete. Hence, we need to play with a proper aspect ratio of a fiber. We need to take a proper length and the diameter. So this aspect ratio plays a very, 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 very important role in the fibers. And also you can see the various types of fibers have been showcased in the photos. You can see the steel fibers, glass fibers, you can see the polymer fibers, you can see the carbon fibers. Okay, and nowadays these particular carbon fibers, they have been using in the strengthening technique, which I am going to discuss in the module 4 or in the module 5. So nowadays this carbon fiber will be used as a reinforcing mat, carbon fiber reinforcing mat, which they are going to wrap on the beam, slab, column. Okay, column, in order to increase the capacity of a column, beam and a slab. Okay, is it clear? So this is regarding a fiber. So these fibers will be embedded inside the concrete member, so that this particular corrosion problem you can protect. Okay, there is no need of worrying about this corrosion, because these fibers will not so prone to the corrosion problem. Is it clear? Okay, so this is regarding your non-ferrous reinforcement. Hope the concept has been clear. Next, coming to the one more thing, okay, the most commonly used is sixth one, epoxy coating. epoxy coating. So now the one more corrosion protection technique we can go ahead in order to protect the steel from a corrosion is epoxy coating. Epoxy coating. That means I am going to lay the epoxy, okay, on the surface of a reinforcing bar, okay, to protect the steel from the corrosion. First of all, epoxy. Epoxy is a polymeric material. It is a resin. It is a resin, polymeric resin, I can say. And this particular epoxy will be laid on the surface of a reinforcing bar as a powder material, in the powder form. Okay, the process will be there in such a way that take a rebar, that rebar will be sent inside the epoxy bath. In that particular epoxy bath, what they are going to do is, they are going to spray the epoxy. They are going to spray the epoxy to the required thickness. To the required thickness. So that particular epoxy in the powder form will be laid on the reinforced bar or a rebar. So that particular epoxy will be of sufficient coating thickness, okay, will be sent, okay. Then it will be cured for certain time, because that whatever the epoxy you have been laid, okay, so that will be in something like in a fresh state, okay. It requires sufficient amount of drying, okay. After drying, you can see how it looks, you can see the process, okay. It will be in the greenish color, that, okay, the greenish color, that greenish color coating will be the epoxy coating which I am going to do. Okay, so this particular epoxy coating is very commonly done, okay, and this epoxy coated steel is widely used in bridges, okay, when they are going to construct with the bridges, okay, where the coastal area, that means the coastal area, or what I can say the marine structures are there, we are going with this epoxy coated steel. And one problem observed by the researcher in the epoxy coating is, the epoxy coated steel bar will not bond properly to the concrete member. The epoxy coated steel bar will not properly bond to the concrete member. You already know that in the reinforced concrete structural elements, you people have been learned, okay, the proper bonding of between the material, that is steel and concrete, is essential. Here that problem will be there, as a researcher has notified, okay, there will be no proper bonding between the epoxy coated steel bar and a concrete. But this nowadays they have been overcoming, and this particular epoxy coated steel they have been using widely in the reinforced concrete structural element. Is it clear? Okay. So next, so this is the one more method. So till now I have been discussed the 6 corrosion protection techniques, starting with cement slurry coating, okay, then cement emission coating, polymeric coating, galvanization, and today we have discussed the cathodic protection. Next, we have completely removed the reinforcement and we have added the fibers, that is non-ferrous reinforcement. So that means I am trying to modify the reinforcing material. That means I am protecting the reinforcement. Okay, till now. So now the 7th corrosion protection technique which I am going to do is, why can't we concentrate on a concrete? Okay, you know that the reinforced concrete is a composite material of steel and a concrete. Till 6, okay, the corrosion protection technique have been concentrated more upon the steel. Okay, if you are going to protect the steel from a corrosion, then the reinforced concrete structural element durability will be very good. Okay, is it clear? Now, what I meant to say in the 7th corrosion protection technique here is, if I am going to protect the concrete, there also I can prevent this corrosion. How? Let us see. The very first thing is water cement ratio. If you go into restrict or use a proper water cement ratio inside the reinforced concrete member or inside the concrete member, then you can prevent, because you know that reduction in water cement ratio will increases the compressive strength. How? Because if you reduce the water cement ratio, the voids will be reduced. The voids will be reduced. Okay. So, but by that reduction in voids, you can create a good compressive strength. If a compressive strength is more, automatically then it will create a good barrier inside the concrete member, so that no external agents or villains that can enter inside. So you need to be very cautious regarding water cement ratio. That's what I have been highlighted in the module number 1 also, in the module number 3 also. You need to be very thorough with the water cement ratio. If you give a more concentration upon the water cement ratio, you can prevent this, what I can say, the corrosion problem, so that you can enhance the service life of a building. Is it clear? Next is, I can go ahead with the high cement content. High cement content. So, by using high cement content, you can prevent the corrosion. You already know that. Okay, if I am going to dip the rebar in the cement, that means, okay, if cement slurry coating has been provided on the surface of a rebar, okay, I can prevent the corrosion. Here also the same thing. You can, if I am going to improve the cement content, if I am going to increase the cement content inside the concrete element, I can protect the corrosion. But that whatever the cement content you are going to use should be in the permissible limit. So that is very important also. I cannot say, use a cement content as I stated. Okay, because I have stated high cement content means I cannot use more cement content, so that I can restrict. So by minimizing or by using the cement content in the permissible limit, I can go ahead with the these things. Next is curing. Okay. By proper curing, you know that the curing is initiation of hydration inside the concrete member. If curing is properly done, then concrete will be properly hydrated. If hydration process is proper inside the concrete member, automatically you can achieve a good strength inside the concrete. If hydration is improper, that means your curing has not been done properly. So all these things are interconnected. Proper curing will lead to the proper hydration. Proper hydration will lead to the good strength. Okay. So by these three aspects, you can prevent or you can modify, if you modify the concrete properties in these things, or if you take care of these properties in the concrete, okay, you can prevent the corrosion. Okay, all the 6 corrosion protection techniques which have been concentrated on steel. In this particular corrosion protection technique, I have been concentrated on concrete. Okay, if you are going to take care of concrete member, from then also you can prevent the corrosion. Is it clear? Okay, so these are all the corrosion protection techniques which have been discussed from the past 2 sessions. Okay, or I can say including this session. Okay, in the 3 sessions which have been we have been learned the corrosion protection techniques, the various corrosion protection techniques. Okay, which is very important. And one more thing. Okay, you can also think, okay, how to protect this steel from a corrosion, or how to modify the concrete to prevent the corrosion. Okay, I have been discussed 7 corrosion protection techniques. Like this, so many corrosion protection techniques are there. I have been highlighted or discussed the very important corrosion protection techniques which have been highlighted. Okay, and you can also come up with your own protection techniques. That's what have been highlighted in the beginning of the session. You can come up with your own corrosion protection technique so that you can do the projects upon this corrosion protection technique, which is a very, very important in the civil engineering. So with this, I am going to end the today's session with corrosion protection techniques. Okay, thank you.